Okay, dear children, good morning. In the previous video, we learned real numbers and their decimal expansion. Yes, what are real numbers? It is the collection of rational and irrational numbers together called real numbers. So, in previous video, we studied the decimal expansion of rational number. The decimal expansion of rational number is of how many kinds? Recall at previous video? Yes, very good. Is of two kinds. One kind is, yes, anyone? Okay, terminating decimal expansion. What is the another kind? Another kind of decimal expansion of a rational number? Non-terminating recurring decimal expansion. Okay. What is the decimal expansion of irrational number? How it is? That is of the form non-terminating, non-recurring decimal expansion. Okay. So through that knowledge, we solve the exercise 1.3 today. So this is the first one. Write the following in decimal form. Write each in decimal form, means you have to write the decimal expansion and say what kind of decimal expansion each has. So dear children, these all are rational numbers. They have only of two kinds: terminating decimal expansion or non-terminating recurring decimal expansion. So anyway, we check. First we write the decimal expansion. Consider the first one, 36 divided by 100. If you divide 36 by 100, 36 is smaller than 100. So write a decimal in the question place and write 10 with 36. Now it is greater than 100, 360. So near to 360 in 100th table is 300. 100 3 ja 300. So 0, 6 minus 0 is 0. 6 minus 0 is 6, not 0. 3 minus 3 is 0. Now it is 60. We already given a decimal in the question. So then write one more 0. 100, how much is 600? 100 6 ja 600. 0 0. So now 36 divided by 100 is the given rational number. What we obtained here? That is 0.36. Okay. So division process is completed. Then which kind of decimal expansion it is? Terminating decimal expansion. Very good. This is terminating decimal expansion. Okay. Then see the second one. Dear children, observe here. In your previous classes you have learned the denominator is 100. Without doing actual division, we can write it in decimal. How means see? Write the number in the numerator, that is 36. How many zeros are there in the denominator? 2 zeros are there, no? So by leaving 2 digits from right to left, put the decimal and write the 0. Yes, this is our earlier knowledge. You no need to divide. If the numerator is divided by 10, 100, 1000, we can write them easily as their decimal expansion. Write the numerator 36 as it is. Count the number of zeros, 2 zeros from right to left. Leave the places as many zeros in the denominator. 2 zeros are there now. So from right to left, leave 2 digits. Then put a decimal. 0. Okay. So this is by actual division. This is by our earlier knowledge. Clear? So whatever it may be, this is its decimal expansion. This is terminating decimal expansion. Okay. How to obtain its decimal expansion? To obtain its decimal expansion, we divide that numerator by denominator. So divide 1, write 1 by divide 1 by 11. So now 1 is smaller than 11. Put a decimal in the quotient place, then write 0 here. Again it is smaller. Then what we do? No problem. Use your earlier knowledge. Write 0 in the quotient place. Write 0 in the dividend place. Now it is 100. So which is near to 100 in the 11th table? 9 ja. 100 9 ja 99. Okay. Subtract 10 minus 9 1, 10 minus 10 0, 0. Again there is a decimal, write 0. Again it is smaller than this. So no problem, write one more 0 in the quotient, write one more 0 in the new dividend. Again it is 11 9 ja 99. 10 minus 9 1, carry 1, 10 minus 10 0, 0. So now there is a decimal, write 0. Again it is smaller than 11. Yes, this is smaller than 11. No problem, don't worry. Write 0 in the quotient place. Take one more 0. Now it is 100. So 11 9 ja 99. 1 0 0. Dear children, this goes on same. Here also it goes on. Okay. So mention. This is division process not ends. Okay. See the digits 09 09 09 09 09. It goes on. So these two digits starts repeating. So then what is the decimal expansion of 1 by 11? The decimal expansion of 1 by 11 is 0.090909 so on. Yes, in previous video I said how to write this symbolically. That is 0. How many digits are repeating? 2 digits are repeating. What are those? 0 and 1. These two are repeating again and again. So write those two repeating digits. Write bar over those two repeating digits. Clear? Then which kind of decimal expansion it is? Division process not ends no. So non-terminating digit starts repeating no. Recurring decimal expansion. So non-terminating recurring decimal expansion. Clear? Okay. Dear children, this is 4 whole 1 divided by 8. This is same as convert. This is mixed fraction. Convert this mixed fraction into improper fraction that you have learned in your previous standard. 8 4 ja 32. 8 4 ja 32. 32 plus 1 33 divided by 8. Okay, mixed fraction, improper fraction. Clear? Then divide 33 by 8. You will get a decimal expansion, and observe that decimal expansion. Right? Whether it is terminating or non-terminating recurring decimal expansion. And this 4th one, 5th one, and 6th one are for your homework. Yes? Make a pair notes. Write all the exercise questions along with answers. One day when school reopens, no, that time we will check your pair notes. Or I will do one thing, that is I will give you one date during this interval. On that date you have to come to school and take signature by me. Clear? So these are for your homework. Okay. Now I will do this one. Dear children, write these two. Now next I will do that 33 divided by 8. Right, pause the video, write the solutions of these two. Dear children, yes, divide 33 by 8. Divide 33 by 8. We will obtain its decimal expansion, which is near to 33 in 8th table. That is 32. 8 4 ja 32. 3 minus 2 1. 3 minus 3 0. So put a decimal in the question and write negative 10. So now which is near to 10 in 8th table? 1 ja 8, 1 ja 8. Yes, 10 minus 8 2. Carry 1. 1 minus 1 0. We already given a decimal. Yes, then write direct 0 in the new dividend. Now it is 20. So 8 2 ja 16. 10 minus 6 4. Carry 1. 2 minus 2 0. There is a decimal. Write 0 in the new dividend. Now it is 40. 8 5 ja 40. So what is the remainder obtained? 0 means division process completed. Yes. So the decimal expansion of 4 whole 1 by 8, that is 33 by 8, is, what is its decimal expansion? 4.125. Yes, 4.125. So division process is completed. Yes, point completed. So what kind of decimal expansion it is? Division process is completed means it is terminating decimal expansion. Terminating decimal expansion. Okay. So in the same way, dear children, do these rational numbers and the decimal expansion. Write the decimal expansion and mention what kind of decimal expansion each has. Okay. Now see the next question. You know that 1 by 7 is decimal expansion is 0.142857 bar. Means when you divide 1 by 7, you will obtain this decimal expansion. Means 1 2 3 4 5 6, these 6 digits start repeating like this. When you divide 1 by 7, 0.142857, again 142857, after this 142857, so on. Instead of writing this, how many digits are repeating? These 6 digits, 3 4 5 6, no? These 6 digits are repeating, no? So that repeating digits we can write one time and write bar over those repeating digits. So which kind of decimal expansion it is? Non-terminating recurring decimal expansion. Clear? So then this corresponds to rational number, that is 1 divided by 7. Using this, can you predict what decimal expansion of 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7 are without doing the long division? If so, how? Without dividing this 2 by 7, yes, will you predict the decimal expansion of 2 by 7 without doing actual division? If so, means how it is? Yes, dear children, it is possible or not without dividing this numerator by denominator to tell its decimal expansion? Is it possible or not this thing? Yes, it is possible. Here they given one thing, they given 1 by 7 and its decimal expansion is given. Through this we can find the decimal expansion of these without doing actual division. How means? See here, 2 by 7. This is the rational number. We have to find its decimal expansion without doing actual division. Okay, see how I will do this. So this we can write 2 into 1 by 7. Yes or no? What is its product? 2 1 are 2. Here is denominator 1. 1 into 7, 7. So 2 by 7 we can write 2 into 1 by 7. Again this thing I will write as 2 into 1 by 7. This decimal expansion is given. How much it is? 0.142857 bar. So then don't worry dear children, just multiply. So 2 7s are 14, 2 5s are how much? 10, carry 1, 11, 2 8s are 16 plus 1, 17, 2 2s are 4 plus 1, 5, 2 4s are 8, 2 1s are 2.0 and write bar over these digits. So when you are free, divide 2 by 7, do the actual division, you will get this decimal expansion, non-terminating recurring decimal expansion. This is without doing actual division. Understood how I did it? So 2 by 7 we can write 2 into 1 by 7, write 2 as it is into 1 by 7, its decimal expansion is given. So write that. So multiply this and this, you will get the decimal expansion of 2 by 7. Okay, I will do another one, 3 by 7. I will do 3 by 7. This we can write 3 into 1 by 7. Both are same. Yes, 3 into 1 is 3, 7 into 1 is 7. Here the denominator is 1. Okay, then see what happens. Write 3 as it is into 1 by 7, its decimal expansion is given 0.142857 bar. Then multiply, its product is the decimal expansion of 3 by 7 without doing actual division. Yes, do multiplication. 3 7s are 21. 3. Okay, dear children, this is the decimal expansion of 3 by 7 without doing actual division. Okay, clear? Okay. Then, dear children, pause the video and write these solutions. We'll come back. Right. Okay, dear children, see the next question. Express the following in the form of P by Q. First, observe the type of decimal expansion of these three. So now observe here, this is 0.6 bar. What kind of decimal expansion it is? So 0.6 bar means this we can write 0.666666 so on. Yes or no? 0.6 bar means 0.666666 so on. So how to write this in the form of P by Q? So this is non-terminating recurring decimal expansion. So this always corresponds to rational number. That is in the form of P by Q. Yes. So which rational number this decimal expansion corresponds? We don't know. So it has a procedure. So just observe that procedure. How I will do? So first write 0.6 bar as 0.6666 so on. This corresponds to a rational number that is in the form of P by Q. We don't know that rational number. Say that rational number is X. Say that rational number is X. Now observe in the decimal expansion that decimal is in front of repeating digit. 6 digit is repeating now. Its in front is that decimal point. So in this case, write this thing as result number 1. Okay. Then, so this is equation number 1. How many digits are repeating? Let's see how many digits are repeating. 1, 2, 3, 4, 5, 6. Don't count like this. How many digits? Only one digit. That is 6. The digit 6 is repeating. So means how many digits are repeating? One digit is repeating. So if one digit is repeating now, then multiply it by 100. Multiply this equation by 100. If there are two digits are repeating in the decimal expansion, multiply it by 100. If there are three digits are repeating, multiply it by 1000. Clear? So here only one digit is repeating, that is 6. So multiply this equation by 10. So do multiplication, what happens? X, we multiply this 10 to both LHS and RHS. So x into 10 is equal to 0.6666 so on into 10. See what happens? X into 10, that is 10x. Yes or no? Then 0.6666 multiplied by 10. How many zeros are there with 1? 1 zero. So move this decimal to one place right. That is its product. That is 0.66666 so on. When a number is multiplied by decimal number is multiplied by 10, count the number of zeros with the 10. Only one zero is there. Then product is write the same number, shift the decimal from one place right, as many number of zeros. Clear? So 1 0, move this one place right. Clear? Then now it is 06.666. 06 means 6. So rub this one. Now say this result is 2. This is result number 2. So here, dear children, in this process we subtract this equation 1 and this equation 2. So now that is equation 2 minus equation 1. Subtract equation 1 from subtract equation number 2. That is, we find the difference LHS to LHS, RHS to RHS. That is, see how I will do. What is the LHS of equation number 2? 10x now. So write 10x minus, what is the LHS of equation 1? X. So that is x is equal to, what is the RHS of equation 2? 6.666661 minus, what is the RHS of equation 1? 0.66661. So what is the difference? See how we will do. 6.66661, 0.66661. What is the answer? So 0.6 minus 0, 6. 6.000 means what? 6. So what is the difference? 6. 10x minus 1x, this is 9x. Then here 9 is multiplied with x. We want that x. Yes, shift this 9 to right side. This becomes division. 6 by 9. Write it in simplest form. 3 2 ja, 3 3 ja. 2 divided by 3. Yes. So what is its p by q form? Its p by q form is 2 divided by 3. When you divide this 2 by 3, you will get this decimal expansion. Clear? This is a method of finding, a writing a rational number whose decimal expansion is given. Clear, dear children? Yes? Shall we move into the second one? Okay, that is different. So write this first one. Okay, dear children, now we move into the second one. Observe. Express this decimal expansion in the form of p by q. So means which kind of decimal expansion it is, dear children? Yes, tell me. That is, write it like this: 0.4 7 bar is there no? That is 7, 7, 7, 7, 7, 7, so on. Clear? So this corresponds to which type of decimal expansion it is? Non-terminating recurring decimal expansion. So this is the decimal expansion of rational number. We have to find that rational number. That is in the form of p by q. What is its numerator? What is its denominator? So this corresponds to a rational number. So say that rational number is x. So here in earlier case we named this as equation number 1. Here don't do the same, because observe the decimal point that is not in front of repeating digit. Our repeating digit starts from 7. These are repeating digits. This is not repeating, 4 is not repeating. But here see, this repeating digit is this decimal is the one that is in front of repeating digit. It's in front. But that is different case. 4 is not repeating. Yes, the decimal is that decimal is in front of non-repeating digits. So this should be in front of repeating digit. So how we move this decimal point to in front of repeating digit? So we shift this decimal to one place right. So that we multiply the equation by 10. Don't say this as result number 1 as earlier case. So now see what happens. We multiply this 10 to both LHS and RHS. 10 into x, 10x, 0.47777, so on, into 10. See what happens. 10x equal to 10 is there now. So shift this decimal to one place right. That is 0.4.77777, so on. So now observe the repeating digit, observe the decimal point that is in front of repeating digit. In this case, say this result is equation number 1. Don't write here directly as equation number 1, because here the decimal is not in front of repeating digit. So in these such cases, first shift the decimal places in front of repeating places. Then here one place we have to shift, so we multiply by 10. So now 0, 4 means 4. Okay. Then observe how many digits are repeating. Only one digit is repeating, that is 7. So again do the same process. One digit is repeating now. So multiply it by 10. Yes. Both LHS and RHS. LHS is already 10x. Again multiply it by 10. So 4.77777, so on, into 10. Write down what is the result product. 10x into 10, 100x. Then 10 is there now. Shift this decimal place to one place right. That is 47.7777, so on. Say this result is result number 2. Again do the same process. Equation 2 minus equation 1. So equation 2 minus equation 1. See what happens. What is the LHS of equation 2? It is 100x. 100x minus what is equation 1? Here it is. What is its LHS? 10x. 10x. So subtract RHS to RHS. RHS of this equation 2 is 47.7777, so on, minus what is the RHS of equation 1? That is 4.777, so on. So 100x minus 10x, yes, it is 90x is equal to, yes, final difference. See, I will do 47.7777, so on, minus 4.7777, so on. Final difference 0, 0, 0, 0, 0.7 minus 4, 3, and right here this is 4 minus 0, 4, 43.0000, like that. So 43.00 means 43. So 90 is multiplied with x. So shift this 90 to right side. That becomes 43 by 90. So this decimal expansion corresponds to which rational number? 43 divided by 90. Thus, this is of 43 by 90. Clear? These are the methods of finding a rational number whose decimal expansion is given. Clear? So, dear children, that third one is there now. That is for your homework. This is for your homework. What is that? 0.001 bar. Very easy it is. Follow the same steps. Clear? Okay. Pause the video, dear children. Write the notes. So, dear children, see the next question, picked one. What can the maximum number of digits be in the repeating block of digits in the decimal expansion of 1 by 7? 1 by 7 is a rational number. It has a decimal expansion. In its decimal expansion, what can the maximum number of digits be in the repeating block? Yes. How many digits are repeating in the decimal expansion of 1 by 17? Perform the division to check your answer. So, I will tell you answer, dear children, when you are free, or divide 1 by 17. Divide 1 by 17. You will get this kind of decimal expansion, that is 0.0588235294117647. After this, you will get the same, that is 0.88235294117647. So the division process takes several steps. Yes. So after 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. After 16 digits, again these 16 digits starts repeating 0.88 like this. Clear? So 0.58835294117647. These 16 digits are repeating. Yes, in this block. So what are the maximum number of digits are there in the repeating block of the decimal expansion of 1 by 17? 16. What is your answer? 16 digits are repeating in the decimal expansion of 1 by 17. Its decimal expansion is this one. Okay, so in fair notes or book, divide 1 by 17. It takes several steps. You have to do those all. At least you should show the 16 repeating digits. Clear? Up to that, you have to do division process. That we will check. This is answer. Clear? So how many repeating digits are there in this repeating block? Yes, 16 digits. This is your answer. Okay, dear children. In the next video, we will discuss some more questions of the exercise number 1.3. Okay, so write the children, dear children. So we'll meet tomorrow again. Bye.